So I'm going to be talking about polarisation and intermolecular forces. So a polar molecule is a molecule in which the distribution of electrons between covalently bonded atoms isn't even. So larger atoms are more electronegative. They exert more of a pull on the electrons due to the positive charge from the protons in the nucleus. The other side has a mostly positive charge. So this difference in electron density is what causes the molecule to become polar, so it forces the molecules together. An example is water. So oxygen has a strong electronegativity, it's negative, so electrons are attracted towards itself. Each hydrogen atom becomes more positive due to the dominance of the protons, shown in figure 1. Dipole moments are a measure of polarity of a molecule where there is a difference in electronegativities between two or more atoms. So a dipole moment is a vector quantity. It's created when the charges are opposite and equal in magnitude and are separated by a distance with a definite direction of charge. So they are measured in debye units, which is equal to the charge multiplied by the distance between the charge. So 1 debye is 3.4 times 10 minus 30 kilometres. So the dipole moment can be calculated using this formula. So U is the dipole moment, Q is the magnitude of the separated charge, and R is the distance between the atoms or the ions. So for a dipole moment to occur, there must be a polar bond, U must be greater than 0, and there must be a direction of charge. So if it's below 0, the molecule and the bond is non-polar. So a similar electronegativity equals a very small dipole moment. A larger difference in electronegativity is a large dipole moment. So if a polar molecule geometry is symmetrical, there's going to be no dipole moment as the charges cancel each other out, as shown in figure 2. A dipole example is water. So oxygen is more electronegative than hydrogen, so it exerts a stronger pull on those electrons. Oxygen also has 2 lone electron pairs, so the dipole moment points in the direction of the oxygen atom. So this dipole moment is the small arrow with a tail on the negative centre and its head on the positive centre. So as it's a covalently bonded compound, water, we can predict it's going to exhibit 3 types of intermolecular forces. So this is a physical force of attraction or repulsion between molecules and other atoms that are close to one another. So in increasing order of strength, we have London dispersion forces, so they're the weakest of intermolecular forces, and it's an interaction of many dipoles. So electrons unevenly distributed create a spontaneous temporary dipole. In water, this occurs between the positive hydrogen and the negative oxygen. So the more electronegative an atom is, the stronger the London dispersion force. A dipole-dipole force is a second. It's a strong interaction of 2 neighbouring polar molecules with permanent dipoles. So in water, oxygen attracts the positively charged hydrogen of another molecule. The larger the polarity, the stronger the dipole-dipole forces are. Hydrogen bonds are the strongest intermolecular force. So in water, these are formed when the partially positive dipole of hydrogen is attracted to the partially negative dipole of another oxygen in a neighbouring molecule. So the large electronegativity difference in the small atomic size of hydrogen gives it several unique properties. So its high cohesion means it's able to form and hold on to bonds with other water molecules, which creates a high surface tension. This is why animals can walk on water. Its adhesive properties between other molecules of a different substance, of which it can form a hydrogen bond, mean capillary action in a narrow tube takes place. It's an excellent solvent, so it's capable of dissolving more substances than any other liquid. Many organisms use water as a solvent to keep us alive, so the kidneys. Ice is less dense than water. Its crystalline structure spaces molecules apart more evenly, solidifying when it reaches 0 degrees. So this insulates organisms underneath the ice to survive. The high specific heat capacity remains in a liquid form over a wide temperature range, so lots of energy is needed to break those hydrogen bonds, raising the temperature. This regulates the temperature in oceans and lakes and gives it a high boiling point. The high latent heat of vaporization means it's not prone to sudden temperature changes, so lakes don't dry up easily, and mammals and plants sweat. So a polar molecule is an uneven distribution of electrons in covalently bonded atoms. A dipole moment is a measure of the polarity of a molecule. Water contains London dispersion forces, dipole-dipole and hydrogen bonds, which many physical properties of water result from. The end.